PowerPoint can be found on my homepage underneath statistics for today. The first problem says, find an equation of a line of best fit. Can you shut the door for me, please? So, line of best fit. A few things to keep in mind. In the past, it's been the idea of some students that a line of best fit is like connect the dots. That's not true. A line of best fit takes the data points that you're provided, and it literally takes an average of them. I've heard many students say that Ms. Castro would require you to use an ID so you have a nice straight line. Okay, it doesn't go through the first point necessarily and the last point, it's the average of these points. And we can see from looking here that this would be an example of linear regression, because if you do just with your eyes here, if you approximate a line of best fit, we can see it as a straight line. So we're going to use a calculator to find the line of best fit. I looked at these points and I approximated. So your x-axis represents the number of designs. Your y-axis is total sales. So for instance, if I go over to 10 on the x-axis and I go up to 5,000, that's how I came up with these points. This was not given to me. I took these from looking at the graph. Okay, please make sure all cell phones are taken away. If not, you'll get it back on Wednesday. All right, so please on your calculator do second plus 712. Second plus 712. Hit stats and edit. The L1 column represents your X values. The L2 column represents your Y values. After each entry, press enter. If somebody needs to move closer to the board so they can see, feel free to do that. Okay, the next thing we're going to do is we're going to hit stats and we're going to go to calculate. This is not new for you. We learned how to do this back in August. We know this is an example of linear regression because we can see the line of best fit will be a straight line. So you're going to use the cursor and scroll down to linear regression. And I know we have two different types of modes on our calculator. This is a newer brand. Yours may be older. So for some of you, you only have to press enter twice. On my calculator, I have to press enter until I get to calculate. Regardless, we should come up with the same answer. Okay, I'm going to go to the next page. So this is my answer. So I'm going to start by writing down, give me 1 second here. I got to flip this over. There we go. My apologies. So these are the directions that I asked you to do. And this is the answer I have when I round to the nearest 100th position. So before we go any further, I want you to check with one person in your group. I'm going to count to 10. Make sure that both of you understand how to get to this point. Don't leave anybody out. Ready, begin. Does anybody have a question for me that I can help you with to get to this point? Okay, we're going to go on to part B. This is part B. So part B says based on your equation. So I'm going to write the equation down. So based on your equation of the line of best fit, predict the total sales, what the total sales will be when the store has 185 different rug designs. So if you remember from looking, rug designs is an X value, total sales is a Y value. So we want to know total sales. We want to find out what Y is, and we're given what X is. So I'm going to substitute in for X, 185. Then I'm just going to do simple operations. 288, 81 times 185 plus 2810.50. Can you please confirm, are you getting the same answer that I did? Yes, no?
Yeah.
Okay, so this is an estimation. If there is 185 different rug designs, we can assume that the total sales will be this amount. Okay, I'd like you to do a quick self-assessment on this. On your paper, if you fail, remember your test is Friday. Some of you scored very well in the last test. Others were probably disappointed. So you want to be able to do well with only one test remaining after this Friday. If you feel like this is a problem, you already understand this, please put a light, very light X through the problem. If you feel like you should review it, please circle it. On everybody's paper, you should be putting an X through or circling based on your own personal understanding. Suppose the average weight of an NBA athlete is normally distributed with a mean of 200 pounds and standard deviation of 25. Use the graph to approximate the probability that an athlete weighs less than 230. So we need to make a graph. So let's make a bell curve. We know the mean is 200 pounds. We know the standard deviation is 25. So one standard deviation above would put us at 225. Two standard deviations above the mean would be 250. Three standard deviations above would be 275. Now I'm going to go back down to one below, two below, and three below. Approximate the probability that an athlete weighs less than 230. Well, 230 is right about here. So less than 230, we're looking at this part right here. Well, here's the problem. 230 does not lie on one of the columns. So when it does not lie in one of the columns, we need to use the calculator to do the work for us. So what do? We're going to come up with 4 values. The mean is always the third. The standard deviation is always the fourth. The low end goes first, the high end comes second. So this says find the probability, and we're going to approximate that an athlete weighs less than 230. That means we go all the way up to 230, but we never go past it. So 230 is our largest number. We're not given a small number, so we will put in negative 9999. Now on your calculator, please hit stat. My fault, please hit vars. How about second vars, if I get this right? Second vars. Go down to normal CDF. And I know some of us have different looking programs. So mine is a newer version. Many of you have an older version. If you have the older version, you'll plug in the numbers, separating them with a comma. Somebody that has a newer version will type it in like I am. And if we are going to round this to the nearest 10th of a percent, we could say that approximately 88.5% of NBA athletes weigh less than 230 pounds. By show of hands, how many were able to come up with that? Okay, do me a favor, please be honest. Go to your paper, please make an X or a circle based on how you need to study for the next test.
X is good, like
X is I don't need to refer back to this. A circle is I should review this problem. Thanks for clarifying. If you go to the PowerPoint, that will be listed on the board, or you rewatch this video. Again, these are the numbers and how we're going to plug them in. Okay. Yes?
What's the process of the button clicking to get to it?
Sure. The process of hitting the buttons, sorry, and I confused you earlier, is going to be second vars, go down to normal CDF, and then plug in the numbers, separating them with commas. Does that make sense, Santos?
Yeah.
Okay. Have one person per group read it while I read it out loud. Suppose the average NBA athlete is normally distributed with a mean of 200 pounds and a standard deviation of 25. Use the graph to approximate the probability that an athlete weighs more than 175. Bless you. Bless you. So, we want to know the probability of an NBA athlete weighing more than 75. Well, I can refer back to this. Because 75 lands right here, more than 75 is to the right. So you should already have these memorized. This is
34.
34. What's the next two?
13.5.
13.5 and 13.5. 2.35 and 0.15. Remember that our bell curve is symmetrical. So I'm just going to add up everything to the right of this line. And I'd like you to do the same. And please check with me. I believe it comes up to 84. Can you check with me and see if that is correct?
For Tuesday, the testing.
I'm gone today. I'm gone tomorrow. I have a sub coming in.
You have
because I'm sick.
Okay, yeah.
But there will be somebody here until 3.
Right, until 3, so I need to get a lab for 11.
Okay.
If you got a 7 here, I'm not gonna mess with it.
Okay. And then
Okay.
I'm not here at all on Thursday because of testing time.
Okay, wait, Thursday, you're not in here at all?
No, because of my
So
class.
the classroom will be open.
You got it.
Okay, thank you.
Yep, no problem. Do you guys agree? Was it just 84? Okay. Just so I know, can you do a thumbs up, thumbs down right now with your understanding so far? And I'm totally curious, is there any problem like this on an AZ Merit? No. Okay. Here we go. One person reads it out loud in your group, please. What was the average weight? So a common question we've had, maybe not now, but when we first started learning this is how do I know when I use normal CDF or when I can just refer to a normal distribution curve? We're looking from 200. Okay, awesome. It falls right on this, on a column. And then was it 215?
Yeah.
But 215 does not fall on a column, which means we do need to use normal CDF. So with your group, I'd like you to figure out the answer, and then you'll check it with mine. Second bars, normal CDF, your low number in this case is 200. Your high number is 215. Your mean is 200. Standard deviation is 25. Press enter. 22.6% approximately. Thumbs up or thumbs down if you were able to come up with that answer. Hey Zeus, does your group have any questions?
No, we're still confused on whatever. Oh, you got it.
You sure?
Yeah, we're good.
Okay. Do me a favor, go back through the 3 we just did. Again, you're going to put an X or circle based on your understanding and what you need to study before Friday. So when you think about bacteria growing in a dish or cancer, most often that type of cells grows very rapidly and it grows exponentially over time. So that's one fact that you learned freshman year. So now we're going to apply that, and we want to come up with an equation that's going to mimic this. It's going to model this. So in the table, P represents the population in millions of total bacteria after T hours. So time is always going to be your X. In this case, population in millions is your Y. When you plug it in, your L1 is X, and your L2 is Y. So let's clear this off real quick, clear it out. Let's go to Stats and Edit. And now please plug in the numbers for L1 and the numbers for L2. Once you plug in the numbers, and we know this is going to be something that is going to model exponential, Garcia, head up. Hit Stats, go Calculate, and keep scrolling down until you find what represents exponential regression. Press Enter. And then let's round our answer to the nearest hundredth. So remember, our number outside is our initial number, and then this is our growth rate. So 3.00 goes out front. 1.21 is going to be your growth rate. So it's looking like this. If you didn't get that, it's probably most likely because you entered one number wrong into the table. All right. Again, a circle or an X, please. Circle or X on your paper. This is a very simple concept, but a lot of you probably have forgotten how to find the z-score. A normal distribution has a mean of 456 and a standard deviation of 3. Find the z-score that corresponds to an x value of 494. So your data point is 494. This is probably an easy one to do mathematically. Again, you may have forgotten z-score. So z-score equals your data point, subtract the mean, divided by standard deviation. Data point, subtract mean, divided by standard deviation. So in this particular case, and they put value score, which is the same as data point. We have 494, subtract 456, achieve this answer, then divide it by a standard deviation of 3, and this is what we have for an answer, a z-score of 12.6 repeating. You absolutely will have to find a z-score on your test. So if this is something you're not comfortable with, please put a circle around it. On to number 5. I'd like you to forget about these possible answers. The average GPA of a high school class is 2.56 with a standard deviation of 0.8. Assuming a normal distribution, estimate the probability that a randomly selected student has a GPA between 1.85 and 4.26. So let's first draw a normal distribution curve. We know the average, or the mean, is associated with 0. So do 2.65. For speed reasons, can I have all the males do the next 3 standard deviations to the right? All the females, please do 3 standard deviations to the left. Go ahead. Okay, Henry, please read me your answer.
2.73 and 2.81 and 2.88.
Okay, going the other way, Michelle. Okay, so Michelle, please plug in 2.65, and then we're going to go to the left of the mean. So you're subtracting 0.8 as you go to the left.
He added,
Hold on one second. Let me go this way, and then if you see a correction that needs to be made, let me know. Go ahead. Let's check here real quick. 1 second. Now Santos has me alarmed. So let me make sure here. So if I add 0.8,
yes.
oh, 0.8. Now, did I tell you guys 0.08? Did I say the wrong number is what you're saying? Oh, he just added the wrong number. Okay, I got you, Henry. That's all right. Can everybody please change these?
4.25,
Thank you.
5.5.
Okay, is that agreed upon now? All right. So we want a GPA that's between 1.85, we happen to be lucky, it falls in one of the columns, and 4.25, it also falls in one of the columns. So we're able to add up in between here within your group. Please talk about the percentages that fall in between each column and then add them up to get an answer. Begin.
Yeah.
81.5%. Do you agree with that answer?
Yeah.
So we're going in between these two columns, we add it up, and we do come up with 81.5. Okay, going on to number 6. We are going to draw a scatter plot. So pay close attention to this, something you learned freshman year. Please do second plus 702 on your graphing calculator. First of all, when you see these points, if you were going to draw a best fit line, does this look linear or does this potentially look quadratic? It looks potentially quadratic to me. So let's see what we get here, all right? So we have these points here. Let's first just plot them. So I'm going to go through this slowly because this was confusing to students in a previous hour. Please follow along in your calculator. Hit Stat, Edit, bless you. In L1, let's plug in the X values. Notice as I plug them in, they're all separated by a constant value, in this case of 2. Sure. Better? Okay. And then for your L2s, we're going to plug in the Y values. And now we have to create a scatter plot. So you can see scatter plot is listed up here, but first we have to hit the second button and then scatter plot. And at this point, the scatter plot is turned off. So press enter twice. And now we need to adjust our window. So we can see that the X values don't go into the negative. So let's just do -5 just to give us a little room. And I'm going to go about 5 to the right of 12. So I'm going to go up to 17. Same way for the Y's. I said X's before, excuse me. For the Y's, they don't go into the negative. So let's start with -5. And I'm going to go 5 above the Y value of 16 to 21. When you're done, hit graph. Does this look like what we see in our picture to the right? Yes? Okay, so I want to show you back to what you learned freshman year, how you can tell if this is quadratic. First note that we have a constant value on top going from one number to the next. So we're going to, it's called the first difference. How do I get from 2 to 4? You should be doing the same in your paper. Plus 2, then plus 3, plus 4, and plus 5. If this number was the same, like plus 2, plus 2, plus 2, or plus 3, plus 3, plus 3, we would say it has the same constant difference, and we would be able to say this is linear. Your first difference is not constant. It's not the same. So let's check the second difference. How do I get from 2 to 3? Plus 1, plus 1, plus 1. So we can see the first change or the first difference is not equal, that it's not constant or the same, but the second change or second difference is the same. When you have a second change or a second difference that's the same, we can classify it as a quadratic function. That's a freshman concept that you do have to know. Okay, so now we want to create a model that fits this data. We know that it's quadratic, and we have this information in our calculator. Please hit Stat, go to Calculate, and now remember it's going to take the average of these points. Go down to Quadratic Regression. How do we know it's quadratic? Because we've checked, and the second change or second difference is constant. It's the same. Press Enter, and we can now write this number down. If you're needing help with calculator operations, feel free to refer to the PowerPoint, which is on my homepage, and it has all the steps to finding this model using your graphing calculator. Remember to put a circle or an X after each problem. Going on to number 7. I'm going to zoom out here so everybody can see it. And in this problem, we're going to talk about population, sample, and possible reasons for something being biased. The librarian invites students on campus to vote for their favorite book. To vote, students must place their choice in the ballot box on Tuesday after school. So there's one option to vote, it's Tuesday after school. As a group, you don't have to write anything down, I just want you to discuss what do you think is the population, the sample, and a possible bias for this problem. Begin. So here we go. This group in front, they're getting a little feisty. I don't want that conversation to go any further. There's going to be no girl fights in this classroom. Because we all know Esmeralda would win. She's scrappy. Okay. So whoever is invited to be a part of this is the population. So are they inviting teachers to be part of this? Who are they inviting? So all students at this school, all students are the population. The sample are those who participate in voting. Now, why could this be biased? If everyone does not have the opportunity to participate, then you can find room for bias. For instance, let's come up with some examples. Maybe there's some sports teams that have an away game on Tuesday. And if there's only one opportunity to place your vote, they would not have an opportunity. Or maybe there's a club that has a meeting, and it's immediately after school. They would not have an opportunity to vote, which makes it biased, okay? Again, circle or X, please. Circle or X. So I'm going to ask that your group gets creative here without any fighting. have one person read this and then talk about it as a group. Go. Thank you. So there's lots of different ideas that we could use. The ones you don't want to use would be like convenient sampling. Like, hey, let me just ask 30 people in my math class and I'll get their opinions. Or what's the other one that's not as good? Convenience or
Volunteer.
self-selecting, or the volunteer one, right? Thank you. So here is one idea that we could use. Make a roster of the 236 members and assign each member a number. Then generate 30 random numbers using a computer program. Read the opinions that correspond to only those 30 randomly generated numbers. Everybody has an equal opportunity from that. Whoever's a member has an equal opportunity. All right, this one is going to be a little more complicated. So before you read this one, for those that have a good memory, we did a problem very similar to this, and it was about Felipe. And Felipe talked about spicy chicken, salads, or the special of the day, and he estimated what he thought people took from the cafeteria. Does anybody remember that problem? Like 2 or 3 weeks ago. Okay? One person per group. It's very important you read this and write down what you think. Extract the important information as one person reads it in your group. Go. So we have two different things we're comparing. Her predictions and what students actually responded to on the survey. So I'm going to go through and I'm going to talk about her predictions. 1/3 pencil, that's one thing she says. And what else do we have? We have 1/3 pen, 2/9 use a felt point pen, and 1/9, geez, they're getting into hard fractions here, and 1/9 of students use crayons. Now, are the predictions right if they're within a couple percentages? Like, for instance, if I said to you, make a prediction on how many students you think choose the spicy chicken. Do they still offer that option?
Yeah.
Okay, and you said, oh, I think 35% of students choose spicy. And then we did the math, and it came up with 1/3, which is 33%. Would you agree those are very close?
Yeah.
Anytime you're getting above 5% or below 5%, then you're probably a little further off, or especially when it gets closer to that 10% range. So pencils, we know, let's find, find a pencil here. 1/3, so let's write 1/3. This is the prediction. And ballpoint pen is 1/3. And felt tipped pen is 2/9. And crayon is 1/9. Now, before we can figure out what the percentages were actually for the results, we have to come up with the total. Please add these 4 up right now. Did you come up with 157?
Yeah.
So right over 157, 157, 157, and 157. Okay, so I'm going to do a percentage here. of the actual responses and a percentage here of the predictions. I'm going to start with predictions. I know 1 divided by 3 is 33%. This is 33%. 2 divided by 9 is 22%. 1 divided by 9 is 11%. Please do the same for the actual responses right now. I'll give you 1 minute. Go ahead. Pick up a calculator and do it. Don't wait for me to do it for you.
Miss, what do you want us to round to?
Round to the nearest percent. Okay, let's summarize the results. So, was her prediction accurate with the actual results for a pencil?
No.
What about a ballpoint pen?
No.
A felt tip pen?
No.
What about a crayon?
Yeah.
Yeah, it was real close. There we go. If you go to the actual PowerPoint, you can see it's done a little bit neater. It's the exact same concept. On to number 10. This is a difficult one for many of you before. Have one person read it, please. Okay, so to do this, the first thing we're going to do is we're going to add up all the different numbers here. So add these up, please, and come up with a number for me.
Which number?
Right here. Come up with, do you end up with 51?
Yeah.
Okay, so that's our total. I would like you to find out a percentage by taking 22 divided by 51, 10 divided by 51, and round to the nearest percent right now. Yes, please. We know there's 360 degrees in a circle. And what we're going to do is we're going to create our own circle based on these percentages and the fact that we know there's 360 degrees in a circle. And then we're going to compare it to the results that have been given. So now I want you to transfer each one of these back into a decimal and take it times 360. Watch me do the first. So I'm going to do 0.43 times 360. I'll round it to the nearest degree, so 155 degrees. Please do that for the next 3, and then we'll get started. Riley, can you help me with the next 3, please? Okay. Does anybody disagree with those? I think it's helpful to use a pencil here. I also think it's helpful to start with the largest degree. Please separate, make a little circle and separate it very lightly into 4 quadrants. These are called sectors actually because they look like kind of like slices of pizza. So we have 4 different sectors. Each one of them we can see has a right angle. That means this is 90 degrees, 90, 90, and 90. So we want our first one to be 155. So if this is 90, and this is 90, I don't want to go all the way over here, that'd be 180, but let's start here. Okay, let's take this, and let's go, okay, here's 90. What is, if I take this 90 and I break it in half, what's 45 plus 90? 135, okay, and I need to get up to, okay, so then let's take this part, and let's break it into 3 portions. So I know this is 45, broken into 3 equal sectors would be 15, 15, and 15. So I'm at 135. 135 plus an additional 15 is, which would be 150, right? Let's just go a little bit past that. Come straight down. This is 155 degrees. It's 43% of the circle, and this is lose a turn. Couple different ways to do this. The next biggest one is 96. So I know, let's go backwards. I know this is 90, and I only need to go 6 more. So let's split this here. Look at this portion right here, the sector, which is 90. Split it right now, so I have 45, 45. Split this 45 into 15, 15, 15. And now here's 90, and I only need 6 more. A little bit more. This is going to be win the game. It's 96 degrees, 27% of the circle. Yes?
I think, I'm not sure, but I think you're off on something by like maybe a degree or 2.
That's okay. I'm just doing an estimation, but a fairly close estimation. Okay? All right. So I've got this one done. Now, remaining here, we had 90, and we took away 6. This is 90, we took away 6, which leaves us with how many? Do the math. This was 90, and then I used 6 of it for this portion. So I am at 84 here. Do I need all of that 84? Pay attention and back. Do I need all of that 84? What portion of this sector do I not need in terms of degrees? I want to get to this. I'll say it again. This sector down below was 90, just like all of them. I went into the sector and I used 6 degrees of it to come up to 96. So there's no longer 90 remaining. There is 84 because I took 6 away. So I have 84 remaining, but I only need 71 degrees. So how many degrees do I want to have left over? 13. Okay, let's come up here. So here's where it starts. Here's that 45. So let's split this into 3 groups. This 45 degrees would be 15, 15, and 15. I don't need an entire 15. I only need 13, so I'm going to go back here. So, and I'm going to color this in just because it's a little bit more confusing. The portion that's colored in here represents this 71 degrees. Oops, 71 degrees. Represents 20% of your circle, and it's skip ahead. The remaining portion you don't need to worry about. We know that this is 36 degrees. It's 10% of the circle, and it's lose the game. So when we look over here, we have lose the game, we have skip ahead, we have win the game, and lose the game. Turn to your partner. The order you put these in does not have to match our order, but the approximate area should equal ours. Talk to your partner. Do you think they're the same? I'm not hearing enough talking in groups right now. Does lose the game here appear to be the same amount of area as lose the game here? I agree.
That's true.
Okay. Does win the game here appear to be the same amount as it is here? Because it has to represent, win the game has to represent 96. 90 would just be like right about here, right? Do you see how it's not even past 90? So this is no. The reason why is we know that win the game is not containing enough space or enough area within the circle. Okay. This is another formula you are going to have to memorize, just like the Z-scores. So margin of error. What does margin of error mean? The more people you survey, the more results you accumulate, the more accurate your results are. So the more people you survey, the lower the margin of error. The fewer people you survey, the higher the margin of error. The N represents the number of people that are polled or surveyed. If 2,159 students are polled on school lunch, what is the margin of error? Round your answer to the nearest tenth of a percent. So we can go 1 divided by the square root of 2159 and round it to the nearest tenth of a percent, which would make this we're going to round 2.2% with a plus or minus in front. Note that is a formula you have to have memorized for your test on Friday. Remember to circle things, or to put X over it if you don't need to review it. We know that 65% of students love school lunch. 350 students took an opinion poll. What percentage of intervals represents a true population that loves lunch? So let's figure out the margin of error. We know 350 students took a poll. So let's figure out the margin of error. 1 divided by the square root of 350. Our margin of error is plus or minus 5.3%. So we're looking for the true interval that represents this population. So you're going to take 65 and you're going to add this percentage, and take 65 and subtract this percentage. Please go ahead and do that. Can you tell, is the sound coming this way or that way? Okay. So first you come up with the margin of error, and then again we're going to add it and subtract it. Have one person in your group please read this. Okay, well, let's look at the important information. So I've bolded in here the important information. So we have 2, the mean time for falling asleep with a rocking chair and the mean time without. So we have these 2 numbers. We know that it's normally distributed, and this is the standard deviation. Is everybody understanding that so far? So this is what we have for these 2. So let's draw a little graph. So we start right here. It says the mean is 0. This would be 2.2 because that's the standard deviation. 2.2 plus another 2.2 is 4.4 and 6.6. Then obviously we could go down. How did I know this? The information was given. The mean is 0. Remember, the mean always matches up with the center of the normal distribution curve. The standard deviation is 2.2. And they want to know, are Londra's results statistically significant? So how do we do that? 1 second here. We're going to start by subtracting. So we are going to subtract without a rocking chair, the average without a rocking chair, from the time with a rocking chair. So we're going to subtract the 2 numbers we have to get 2.5. We should be writing this down right now, unless this makes a lot of sense to you. We're subtracting the 2 averages, and then we're going to go back here and we're going to find it on our curve. 2.5 would be, well, here's 2.2. 2.5 is like probably right about here. So do we consider 2.5, and I achieved that number by subtracting the 2 numbers they gave us, do we consider that to be statistically significant or insignificant based on what you learned in March? Insignificant, and there's 2 reasons why that I'm sure a lot of you have forgotten. As a group, what are those 2 reasons? It's in the middle, 95th percentile on a normal distribution curve, and it's between 2 standard deviations above and below the mean. Thus, it is considered statistically insignificant. Good. All right. Survey, experiment, and observational study. So surveys are like when you go out and you poll people, you ask them to fill something out, you get their actual responses, written often as written responses. An experiment is when we split up a group. We have a controlled group and a non-controlled group, and then we analyze the results against each other. An observational study is somebody is literally sitting back and they're observing what's happening. Oftentimes with observational studies, the problem occurs is if you're observing something and you're basing the person's emotions on, for instance, if we're doing an observational study about homework, how many of you understand, be honest, understand that generally if you do your homework and you do it to the best of your ability, generally your test results will be better than if you didn't do it? Hands up high. Okay, for those that did not raise their hand, thank you for being honest, but I'll just let you know you haven't caught on to education yet. All right. But if somebody was going to observe you, and they're going to observe whether you do your homework or not, and they're going to observe maybe your behavior or your attitude towards it, they would probably think, yeah, this person doesn't perceive homework as being that important. Just know that next year, based on what classes you go into, there's no ifs, ands, or buts. You have to do your homework every time. And so if you have not heard, they do cuts. Like pre-calculus, they do cuts. After the first week, there's cuts. You don't make it. Second week, third week, they do cuts. The problem is once you're dropped from pre-calculus, you have to find another math class to graduate. By this time, dual enrollment trigonometry is filled up. Normal trigonometry is filled up. Now you're going to be placed into a class with students that may not be at your math level. Okay? So it's very important that you do your homework and that you're ready for those weekly tests at the very beginning. So that's just a little side note. I would like you to read each one of these and decide which one do you think is survey, experiment, or observational study. Go. So the last one, you're asking the person, okay? You're getting personal feedback. This is going to be an example of a survey. Here you're dividing groups up. You have a controlled and non-controlled groups. This is an example of a experiment. And here you're just monitoring. You're watching. This is observational study. Okay? Explain which method would be most reliable. An experiment is always going to be most reliable because you can examine and analyze results from a controlled and a non-controlled group. We are almost done. Number 15, one person reads between your group. Go. So we want to find the range here, the true range. So please take 52.3% males. Please take 52.3%. I'd like you to add 1.2% and subtract 1.2%. Females, you're going to represent the ones that do not like school lunch. Take 48.1% and add 1.2% and subtract 1.2% to get the range for me. Go. Okay, males, let's call on Santos. Do you have the answers? For like school lunch, what is your range? 51. Males, do you guys agree with him before I graph this? Yes? Okay, so just watch. I'm going to go 51.1. So here's 45, 46, 47, 48, 49, 50. So here's 51, 51.1, 51, 52, 53, 53.5. This is the true range and say, hey, I like school lunch. Okay, can you help me out, Isui? What is your range for not liking? Okay. So now I'm going to go 46, 45, 46, 46.9 right there, and 49.3. 6, 7, 8, 9. Here's the true range for do not like. So do you believe that these two boxes are clearly marked? Is there any overlap? If there's no overlap, then it's very clear for us to see the range and say, yes, I don't like it. I'm sorry, yes, I like it, or I don't like it. So explain your answer. This is the range I was provided by you. And since there's no overlap, the survey does show a clear majority that are in favor of the school lunch. Maybe so. With a margin of error between the following. Okay? All right. I think 16 is our last one. Okay. Here we go. Don't overthink this. One person reads it out loud. Begin. So could we assume that because of what Ronald said, we can assume that majority of all students believe Larry Fitzgerald is their favorite player on the Cardinals? What is the reason why? He didn't ask enough people, yeah. So the sample size, the people that actually participated in giving feedback, was not enough. What if he would have asked something like 100 people on campus? Would that be a little different? Yeah. Okay. Here is our last one. Is a bonus question. It's not too hard here. One person per group. Please read it. Okay. The questions for you is which sampling method is more likely to be representative of the total population? And explain why explain why the other method might not be representative, might not give a representative sample of the population. So, which one is better, do you believe? Okay, and why do you believe that is? It's random and it is throughout the entire day. Good job.